In this tutorial, the bump effect appeared to be amplifying the light. Now, Peter came up with a suggestion that perhaps this was a result of increased surface area, but with bump mapping, it's not really the case. It's adjusting the angles at which the light's getting reflected, but it's not physically increasing the surface area as you observed, because it doesn't create geometry, unlike displacement if it worked. And I don't know what the situation with parallax mapping would be. That'd be an interesting one to test. But in this case, we're going to look at bump mapping, the way it works and how it interacts with reflection correction, because I believe this might be the answer as to what's going on here, is the way it's responding to this control. Because I've tested it and it does seem to affect the light levels. So we'll set up a situation. First of all, I'm going to create a sphere. I'm just going to copy it a bit. So I'm just creating a little stack of spheres as something to compare with, so we can have this talk about the theory of bump. So there's some spheres, and I'm just going to drop those into the surface of this infinite plane. So there you go. This is going to be a series of hills. Now I want to create a bumpy material for the infinite plane that simulates that effect, sort of. So on the plane, material settings, bump height, hold shift key down, go into the library, bring out basic, and this basic sign function here could look a bit like, if we look at the bump, a series of hills. And so I'm going to apply that parametric and actual selection, and then we'll give it some bump. So this is our hills, and what I'm going to need to do is have a look over the top here. So not quite to scale. If it's parametric, I can scale the infinite plane itself and bring it into an approximate situation where it's looking very similar. Because the idea is to make a quick comparison between these two and discuss the differences in the way that they're affecting or simulating the bump. So our bump mapping function doesn't create real geometry, it creates the effect of the geometry being there. So these spheres, they're real geometry, and you can see they're being lit on one side from the standard Bryce sun, and likewise a simulated geometry here in the bump mapping, we're getting lit from the side. So this is the front end that's facing the camera, that's the back which is facing away from the camera. Now if we look from the perspective view, okay, here is the problem we've got with bump mapping. We can see the front of these real geometry hills, but we can't see the back, and one hill obscures the hill behind. With bump mapping, this doesn't happen. So as the angle gets lower and lower, so we're getting to the point where we're sort of at a tangent, viewing at a tangent to the ground, then it becomes less and less realistic. So bump mapping works best of all when you're at a higher angle. As you start to look at a shallower angle, then it becomes obvious that this is a trick. And in this case, if you imagine, if this is fine for a pattern on the ground which is just responding to bump, but if we include reflection and it starts simulating the reflections on the far side of these spheres we can't see, so we don't need to consider those. With bump we do. So this surface is simulating a surface that's turning away from us. So when it traces the ray out from the screen to that surface, it actually generates an angle that would take the ray down through the underside of the terrain there. Not terrain, infinite plane. Okay, so we'll now set things up. I've got a little HDRI that I created. It's not really a HDRI, it's just a low dynamic range image, but the key is that it's got front, right, left, right, up, down on it in different colours, so we can use this to orientate ourselves in this scene. So I'll add it to the sky. I don't need to worry about generating light, except to turn the sun back on, and then we'll go into the render options and select 360 degree panoramic, so you can see where we are with this setup. Okay, I'll need to turn the atmosphere off because I can see the sun in this scene, so I'll set the atmosphere to fully black there if I can. I think it's done grey, black, that's better. So there we go, front, left, right, back, up and down. And then I'm going to make this material reflective and we'll see what happens. So this is the issue. Where the view would be providing an angle that would be going down through the surface, it just takes it tangentially along the surface. So these letters here, the bit where it's hitting the horizon, just gets stretched down. which is why they've ended up like that. And in this case, where the F is, that's got stretched down too. I'll switch back to perspective projection. We'll have a closer look at what's going on with these hills. So here, where it continues down, you can see there's like a straight line, and this effect becomes more exaggerated. We go into the material lab and we increase the bump effect, because it'll mean that the steepness of the bump, not described that very well. Let's say I'll just demonstrate with the spheres. This is what's happening when we amplify the bump effect. You're getting this kind of effect. So in fact, you've got very sharp surface at the front, and you've got more that you can't see. There's an increasing amount that you can't see. So when it's very flat, of course, we can see further around the curve. So if you imagine a low bump, so make these hills very flat, we can see more of the top because we're at an angle and we're looking over them, and that represents a situation where we've got low bumps. So if we put 10 down, usually between 10 and 20 you're fairly safe. You can see now we're getting no peculiar stretching except close to the horizon, where your view angle where it's meeting the plane is almost horizontal, because the further out the viewing angle gets, the closer to parallel it's approximating to. So eventually, if we were looking out at in an infinite direction, then it would be infinitely parallel. It's converging at infinity. Obviously it's only in computers, and if you're discussing the extreme mathematics of the situation. In the real life, of course, horizon's curved, the world's round, so that doesn't occur. So what impact does changing the reflection correction have? Well, I'll set the bump back up, and hold on these spheres, I can reset them. Okay, and we go to render options, set reflection correction. Where it gathered the information from before, which was tangential along the surface of the reflecting thing, which is the plane, in this case the infinite plane, it now reflects as if it was a flat surface. So it's just like plane reflection. So as you increase the bump effect now, what you find is more and more of the flat surface behaves like a mirror. And you can see now we're just getting a reflection of what's above there. So this is an F, but actually looks like an E because it's being reflected. What all this has to do with my original point, which was this tutorial here, is that what I was using was a radial gel light, where we were using the reflective surface material of the gel light to cast the light back in on itself. And when it was bumpy, it amplified the light. So what I've done is created this sphere, which is just an ordinary sphere, not a gel light, and I'll apply the bumpy material to it. So that's me just transferring that material. I'll get rid of the plane now, and I'll wrap that around our camera. So in this situation now, we'll start with reflection correction off, and I'll just wrap this around the camera, and we'll see what we've got inside this sphere now. Right, contrary to what I thought, when we've got a situation where we've got the bump on the inside of the sphere and it's very extreme, at low levels of bump this is not going to be a problem. Right, we've got 1. So when it's a very low level of bump, there's nowhere in direction we're looking where the bump is hiding the geometry that's behind it. And since we're not right in the middle of the sphere, there's going to be situations where it is. I suppose if I was to move the perspective camera to the origin, and I've not tested this, so this may not work in my favour as far as the theory is concerned, but it's worth trying. So I suppose in theory, if the camera's right at the origin and the sphere's right at the origin, there shouldn't really be anywhere bump height wise that will let any light through, but I bet it does. It does. Okay, so that's a bit fruity really. So we're obviously, the bump height, the edges are exceeding 90 degrees, and what appears to happen is that it goes off tangential to the surface geometry, but because this is a sphere, it's allowing the ray to break through and see the HDRI backdrop. So it might also see parts of its own geometry before it exits. Now if we turn this right up, it's going to see right outside, and this is very bright, obviously, even though we're inside a geometry which shouldn't be allowing any light through it. Now if we turn the reflection correction back on, it should put us into a darker situation. Now I'm not sure where this light's coming from unless it's through the sunlight which is reflecting on the diffuse channel there. Okay, let's get rid of that. Now we should be in darkness. Good. So that showed that we are inside the reflecting sphere anyway. Now there's one or two odd stray pixels, presumably through some kind of rounding errors in the calculation, possibly, or it's reaching its limit in terms of calculation. We've got maximum bump height here, and there's going to be no setting that should let any significant light through apart from these oddments. And we do know that the light can get through the back of bump mapping anyway, but that's a different issue. And if we turn off, then you'll see there's a radical difference. So this is an interesting effect, possibly useful in other ways, but that's about what it amounts to. So I would say if we lower the bump height significantly, it should get quite dark, because there'd be less chance of arriving at an angle where it's going to get out from the surface. So if my theory, where it was getting brighter in the other tutorial, we just brought it up a couple of times now, then that should mean that lower settings for the bump have been more likely to hit the inner surface. Well, here we go, we've got a sort of a transitional now, where the extreme bump's letting so much out and so much is getting reflected back in. And eventually, of course, we get to the situation, I'll double that up to 80, where more and more is getting turned inside and reflected. So, I suppose, let's have a look. Well, it looks like a panoramic projection. That is about the size of it then. Reflection correction. A curious control in Bryce 7.1 Pro.